Probability. A number expressing the probability P that a specific event will occur, expressed as the ratio of the number of actual occurrences n to the number of possible occurrences N, is P is equal to small n by capital N. A number expressing the probability Q that a specific event will not occur is Q is equal to n minus n by n is equal to 1 minus P. Coin has both head and tail. There are two equally possible outcomes when we toss a coin, a head H or tail T. Therefore, the probability of getting head is 50% or 1 by 2, and the probability of getting tail is 50% or 1 by 2. All possibilities H, T. There are 6 equally possible outcomes when we roll a die. The probability of getting any number out of 1 to 6 is 1 by 6. All possibilities are 1, 2, 3, 4, 5 and 6. Marbles, balls, cards. Let's assume we have a jar with 10 green and 90 white marbles. If we randomly choose a marble, what is the probability of getting a green marble? The number of all marbles is n is equal to 10 plus 90 is equal to 100. The number of green marbles n is equal to 10. Probability of getting a green marble P is equal to n by n is equal to 10 by 100 is equal to 1 by 10. There is one important concept in problems with marbles, cards and balls. When the first marble is removed from a jar and not replaced, the probability for the second marble differs, 9 by 99 versus 10 by 100. Whereas in case of a coin or dice, the probabilities are always the same, 1 by 6 and 1 by 2. Usually, a problem explicitly states it is a problem with replacement or without replacement. Independent events. Two events are independent if occurrence of one event does not influence occurrence of other events. For n independent events, the probability is the product of all probabilities of independent events. P is equal to P1 into P2 into so on into Pn minus 1 into Pn, or P of A and B is equal to P of A into P of B minus A, and it's P of A and B is equal to P of A into B, where A and B denote independent events. Let us look at an example. There are two sets of integers 1, 3, 6, 7, 8 and 3, 5, 2. If Robert chooses randomly one integer from the first set and one integer from the second set, what is the probability of getting two odd integers? There is a total of 5 integers in the first set and 3 of them are odd. 1, 3, 7. Therefore, the probability of getting odd integer out of first set is 3 by 5. There are 3 integers in the second set and 2 of them are odd, 3, 5. Therefore, the probability of getting an odd integer out of second set is 2 by 3. Finally, the probability of getting two odd integers is P is equal to 3 by 5 into 2 by 3 is equal to 2 by 5. Mutually exclusive events. Shakespeare's phrase, to be or not to be, that is the question, is an example of two mutually exclusive events. Two events are mutually exclusive if they cannot occur at the same time. For n mutually exclusive events, the probability is the sum of all probabilities of events. P is equal to P1 plus P2 plus so on plus Pn minus n1 plus Pn, or P or P, A or B P of A or B is equal to P of A plus B P of A plus P of B, it's A and B denotes mutually exclusive events. If Jessica rolls a die, what is the probability of getting at least a 3? There are 4 outcomes that satisfy our condition. At least 3. It's 3, 4, 5, 6. The probability of each outcome is 1 by 6. The probability of getting at least a 3 is P is equal to 1 by 6 plus 1 by 6 plus 1 by 6 plus 1 by 6 is equal to 2 by 3. Combination of independent and mutually exclusive events. Many probability problems contain combination of both independent and mutually exclusive events. To solve those problems, it is important to identify all events and their types. One of the typical problems can be presented in a following general form. If the probability of a certain event is P, what is the probability of it occurring k times in n time sequence? Or in English, what is the probability of getting 3 heads while tossing a coin 8 times? All events are independent. So we can say that P dash is equal to P power k into 1 minus P whole power n minus k. But it isn't the right answer. It would be right if we specified exactly each position for events in the sequence. So we need to take into account that there are more than one outcomes. Let's consider our example with a coin where H stands for heads and T stands for tails. So T T T T T and H T T T T T H are different mutual exclusive outcomes, but they both have 3 heads and 5 tails. Therefore, we need to include all combinations of heads and tails. In the example with the probability of occurring event k times in n time sequence could be expressed as P is equal to nck into P power k into 1 minus P whole power n minus k. The example with a coin, right answer is P is equal to 8c3 into zero point 0.5 whole power 3 into 0.5 whole power 5 is equal to 8c3 into 0.5 whole power 8. Let us look at an example. If the probability of raining on any given day in Atlanta is 40%, what is the probability of raining on exactly 2 days in a 7-day period? B is equal to 7c2 into zero point 0.4 square into 0.6 whole power 5. Few ways to approach a probability problem. Let us look at examples. There are 8 employees including Bob and Rachel. If 2 employees are to be randomly chosen to form a committee, what is the probability that the committee includes both Bob and Rachel? Solution. Following the combinatorial approach, we have n is equal to 8c2. The number of possible committee that includes both Bob and Rachel is n is equal to 1. So P is equal to n by n is equal to 1 by 8c2 is equal to 1 by 28. The reversal combinatorial approach. Instead of counting probability of occurrence of certain event, sometimes it is better to calculate the probability of the opposite and then use P is equal to 1 minus Q formula. The total number of possible committees is n is equal to 8c2. The number of possible committee that does not include both Bob and Rachel is m is equal to 6c2 plus 2 into 6c1, where 6c2 is the number of committees formed from 6 other people. 2 into 6c1 is the number of committees formed from Rob, Bob or Rachel and 1 out of 6 other people. P is equal to 1 minus m by n is equal to 1 minus 6c2 plus 2 into 6c1 by 8c2. P is equal to 1 minus 15 plus 2 into 6 by 28 is equal to 1 minus 27 by 28 is equal to 1 by 28. Following the probability approach, The probability of choosing Bob or Rachel as a first person in the committee is 2 by 8. The probability of choosing Rachel or Bob as a second person when first person is already chosen is 1 by 7. The probability the committee includes both Bob and Rachel is P is equal to 2 by 8 into 1 by 7 is equal to 2 by 56 is equal to 1 by 28. The reversal probability approach. We can choose any first person. Then if we have Rachel or Bob as first choice, we can choose any other person out of 6 people. If we have neither Rachel nor Bob as first choice, we can choose any person out of remaining 7 people. The probability that the committee includes both Bob and Rachel is P is equal to 1 minus 2 by 8 into 6 by 7 plus 6 by 8 into 1 is equal to 2 by 56 is equal to 1 by 28. Some tips and tricks to remember is symmetry. Let us look at one example using this. There are 5 chairs Bob and Rachel want to sit such that Bob is always left to Rachel. How many ways it can be done? Because of symmetry, the number of ways that Bob is left to Rachel is exactly half of all possible ways, which is n is equal to half into 5p2 is equal to 10.